a world of blue turning into a wasteland of gray.
What happens to the ocean when every current carries a threat?
My name is Shami Jati Valorosa,
My name is Janica F. Chang, studying from
Negros Occidental High School.
So our study is titled Autonomous Ocean Cleaning Device with GPS-Assisted Navigation and Sensor-Integrated Filtration for Coastal Water Purification and Marine Biodiversity Support.
Imagine a world where plastics outnumbers fish. This is not a dystopian future. This is the reality of our oceans nowadays. The global waste crisis is a major environmental issue caused by excessive waste production and improper disposal, leading to air, soil, and water pollution and serious harm to marine ecosystem. Panwar et al. 2020 estimate that over 8 million metric tons of plastic enters oceans annually, endangering marine life. The construction of a system for monitoring the pollution of water bodies with waste 2024 further reports that non-biodegradable waste continues to accumulate due to the inadequate monitoring systems. In the Philippines, waste generation is steadily increasing while weak law enforcement and limited infrastructures worsen the problem. Coracero 2021.
A major contributing factor is the widespread production and improper disposal of single-use plastics, such as bags, bottles, and food packaging. The Natural Resources Defense Council 2025 identifies cigarette butts, plastic film, food wrappers, and plastic bottles as some of the most common plastic wastes found in the environment. These materials are easily carried by rainwater into rivers and oceans, intensifying marine pollution. Due to the limitations of existing river-based filtration systems, there is a need for adaptive technologies that can operate directly in coastal and shallow marine environments. The study proposes an Arduino Uno-based autonomous ocean cleaning robot designed to filter debris and reduce localized coastal pollution. The system integrates proximity sensors for waste detection, suction and filtration mechanisms for debris collection, and GPS-assisted navigation for targeted movement within designated zones. Inspired by the ecological role of parrotfish, also known as carnate, which help maintain reef balance according to the Nature Conservancy 2021, the robot aims to reduce plastic waste and improve local water conditions. Ultimately, it seeks to support marine biodiversity recovery by creating safer microenvironments in pollution-affected coastal areas.
So here is the design of our device. The device will be an autonomous biomimetic device that will be used for the purpose of restoring marine life with the Bernoulli principle concept. The device will be designed to take in air from through the dorsal fin vents, as well as draw in raw ocean water from the ventral intake area with the ejector pump. The water will then be forced to go through a three-special filter designed to pick up debris and impurities in the water, which will be broken down with the internal decomposition mechanism. The water will then be ejected from the mouth area in a high-purity form. The device will be designed to protect the reefs in the long term, as it will be equipped with an internal GPS tracking device that will be used to steer clear of illegal activities such as dynamite fishing. The device will then be able to pinpoint safe marine zones.
The materials that will be needed for the construction of the device are JSN SR04T proximity sensor, ejector pump, 24B propulsion motor, Arduino Mega 2560R3, SS316L 5-layer mesh, NEO M9N module, lithium polymer battery, 5mm LED lights, rubber ring seal, BTS 7960, stainless steel 316, ESP32 cam, IP68 connector, emergency stop button, buck converter, 16 AWG wire, M3M5 stainless steel screw, and ADO blade fuse.
This will be the block diagram of this device, wherein the Arduino Mega 2560 R3 will serve as the main controller. The device will be powered by the LiPo battery and will send energy to every components present for the Arduino to pass it on. The Arduino will have two sectors containing the sensor and the module. The sensor will send a signal to the GPS module for the navigation of safe coastal area. The researcher will then use the propulsion motor for the device to move on the right direction. The ejector pump will then suck in water or air as it flows through the mesh filtration. And this is our coding. This device will be programmed in C++ using the app Visco. This allows the research to upload their code for the Arduino Mega, sensors, LEDs, pumps, and motors.
The researchers will carry out a multi-stage process, commencing with the use of the computational fluid dynamics technique, which is used to optimize the Bernoulli effect while ensuring the internal decomposition system can accommodate varying waste densities. Subsequent laboratory tests are expected to take place in a hydrodynamic flow tank, where the efficiency of the triple mesh filtration system and the beak exhaust, which maintains high oxygen levels, will be calibrated. Marine environments tests are expected to take place in controlled marine environments where the GPS and acoustic navigation system effectiveness, including the drone's ability to avoid illegal fishing frequencies, will be validated. Subsequent shepherd tests are expected to validate the effectiveness of the device in ensuring the local fish populations are directed towards safe marine zones, protecting the waters and the life within the coastal economy.
The researchers will carry out a multi-stage process, commencing with the use of the computational fluid dynamics technique, which is used to optimize the Bernoulli effect while ensuring the internal decomposition system can accommodate varying waste densities. Subsequent laboratory tests are expected to take place in a hydrodynamic flow tanks, where the efficiency of the triple mesh filtration system and the beak exhaust, which maintains high oxygen levels, will be calibrated. Marine environments tests are expected to take place in controlled marine environments where the GPS and acoustic navigation system effectiveness, including the drone's ability to avoid illegal fishing frequencies, will be validated. Subsequent shepherd tests are expected to validate the effectiveness of the device in ensuring the local fish populations are directed towards safe marine zones, protecting the waters and the life within the coastal economy.
And here is our budget plan, with the name of the materials, quantity, price, and total price.
References.
Modernizing the sea, invest now in the blue economy.